Okay, let's finish this one up. So we got to SSA as the third option for using our laws of sines. Now, the problem with this is we have a couple different options. One, the triangle cannot exist. Two, we could have two different options. Three, we have one option. Okay, we did one where we had no solution. We did one with one solution because you had to check both of the possible angles. We got a 31 and 149. The one did not work, therefore we only had one solution. We did a no solution because in this case we had a value of sine. It was equal to a value of sine over 1, which is impossible. That's why this is a no solution. Last one we got to look at is the two solution. All right, so we're going to look at this triangle here. A is 40, little a is 54, and little b is 62. Let's go ahead and draw our triangle. A, B, C. Okay, here's what we have. Fill our stuff in, so that's 62, 54, and 40 degrees. Okay, so we'll fill in my little chart down here. So if I fill this in, I already know that big A is 40. I know little a is 54, and I know little b is 62. That's everything I have right now. All right, so looking at this, we only have one pair of letters that we can really work with, right? This one here. We have A. We have a nice setup for A, so we can do A over sine of big A. All right, so let's set that up. We have A over sine of big A. Now, the only other thing we know anything about is that B. We got little b. So we'll do A and B for our proportion. Whoa. That was nuts. Okay, sine of B. All right, so let's plug in what we know and see where it takes us. So we have 54 over sine of 40 equals 62 over the sine of big B. Okay, do a little cross multiplication here. We have 54 sine of big B equals 62 sine of 40. Okay, so then sine of B will be equal to 62 sine of 40 over 54. All right, now if you're going to trust me on this one, you punch that in a calculator. Sine of B is going to be 0.7380. Okay, that was just straight punching in a calculator. Now I have sine of B is equal to that angle. That angle is less than 1, so we're still good. It's a valid number for that. So we got to find that angle of B. So we're going to have to go inverse sine. So inverse sine of 0.7380 is equal to my B. So my B is 48 degrees. Okay, so 48 degrees. That's going to work because the only other angle I have is 40, so that feels all right. All right, now I also have to do 180 minus that guy. Check both options. 180 minus 48. And that's going to give me 132. Now, if I have an angle of 132 and I have another given angle of 40, together they're going to be what? 172? So do they work? Yeah, both are valid answers. Okay, so both work. So what that does for me, now I have essentially two sets to work with. So I'm going to write down my little chart again. I have two full situations for this triangle. All right, just copy down what I have. All right, so the first one I have B is 48 degrees. Second one I have B is 132 degrees. You guys still with me? Okay. Because now I have two valid answers for B, therefore I have to do this problem kind of twice. But it really comes out to be 1.5. All right, let's go back here. Let's just deal and let's get rid of or get this first triangle setup done, and then move to the second one. Okay? So looking at this one now, I have 40 and 48. So I have 40 plus 48 plus C is equal to 180. So what's C going to be equal to? Good, 92. Okay? So that's going to be 92. Now I'm only missing one side. Let's go ahead and use our proportion here. I like sine A because that's what I had right back at the beginning, so let's do that again. A over sine A is equal to C over sine C. I have 54 over the sine of 40 is equal to C over the sine of 92. So I end up with C is equal to 54 sine of 92 over sine of 40. So then C is actually 84. Okay? So that part there is really no different than what we've done before, is it? Okay? Now, the last thing we got to do is we just got to take care of that second triangle. Because I had that second value that worked, I plugged it down here as well. So let's find that third angle real quick. 40 plus 132 plus C equals 180. Then C is going to be 8. So that got to be 8 degrees. Just a little tiny angle. All right. So now I only missing the C term here. I'm just going to separate that. So I'm going to go back to A, sine of A, C over sine C. Okay. So I have 54 over sine of 40, C over sine of 8. Cross multiply, C is 54 sine of 8 over sine of 40. Therefore, C is 11.7. There we go. 11.7. Questions? Anybody? All right, so again, anytime you have one of these where you only have one angle, if you have an SSA situation, all right, find the second angle first, whatever that comes out to be, then you have to do 180 minus that angle. Okay, if neither of them work, you have no solution. One of them works, finish with that one. If both of them work, finish both of them. Got me? So if you have SSA, you either have no solution, one solution, or two solutions. All right, last thing. Let's use this for an area formula. Okay? So area of an oblique triangle. If you remember, back to our days working with right triangle, the easiest part was 1/2 base times height, right? That was back to the original triangle formula as well. Now, so area of an oblique triangle. Area of a triangle is equal to 1/2 the product of the lengths of the two sides times the sine of their included angle. Right? So their included angle would be two sides, angle between them. Yeah, that's what an included angle is. Now, each one of those would be a different one. So if I have BC, then I have to use sine of A. If I have AB, use sine of C. If I have sides AC, then I use sine of B. Okay, so basically there's three separate formulas there, but they're all exactly the same. They're all equal to the area. So in this case here, so I have a triangle with measurements A is 62, B is 10, and C is 24. Go ahead and draw it real quick so we see what it looks like visually. A, B, C, C, A, B. Okay, so A is 62. B is 10, and C is 24. Okay? Do I have two sides with the angle in between them? Yeah, I do. So therefore, I can use that to find the area of this figure. So looking at this, I have sides little b and little c and angle A, right? So I'm looking at the first setup of the area formula. 1/2 BC sine A. All right, so the area of this guy is going to be 1/2. My B is 10. C is 24. And then I would have the sine of 62 degrees. And then it's really simple. Punch in the calculator. Punch in the calculator, you get 106. 106 meters squared. Questions? So for this, for the area, you have to have something of each letter. Okay? If you got little b and c, you need big A. If you got little a and b, you need big C. All right? Questions, anybody? All right.